All right, next page, number 27. So just a regular old integral on this one. The integral of x squared is x cubed over 3 minus the integral of x is x squared over 2. And the integral of 1 is just x. And I'm evaluating from -1 to 1. Again, I'm begging you, please draw this little template for yourself. Okay, it's going to save you. I know you don't believe me, but it will. Okay, so if I plug this in, if I plug in a 1, 1 cubed is 1, so that's just going to be 1 over 3, minus, if I plug in a 1 into here, that's going to be 1 over 2, and if I plug a 1 into here, it's going to be a -1. Now, going back this way, if I plug a -1 into here, -1 cubed is -1 over 3. Then if I plug in a -1 into there, that's going to be +1 over 2, so it's just -1 over 2. And if I plug a -1 into there, a negative and negative are going to make a positive, okay? Now, you guys, please just don't try to add the fractions together yet. Just get rid of your parentheses next. So this is 1/3 minus 1/2 minus 1. And then let's distribute. So I'm going to get plus 1/3 plus 1/2 and then minus 1. If you notice by doing that, like the -1/2 and the 1/2 canceled out. Then I have 1/3 plus 1/3, which is 2/3, and -1 minus 1, which is -2. Putting that over 1 and finding a common denominator, you're going to get 2 over 3 minus 6 over 3, which is -4 over 3, so it's C. Okay, number 28, very similar to one we just did. So again, this is another split up problem. So if I split this one up, this is going to be the integral from 1 to 2 of 3x over 3x minus 1 over 3x. Okay, then simplifying that, 3x over 3x is 1 minus, and I'm going to rewrite the 1 over 3x as 1/3 times 1 over x, so I can see that 1 over x all by itself. So the integral of 1 is just x minus, and then I have a 1/3. The integral of 1 over x is the ln of absolute value of x, and I'm evaluating from 1 to 2. Okay, again, draw your little template, top minus bottom, and let's go ahead and plug these in. So this is going to give you 2 minus 1/3 ln of 2. I can remove the absolute values now because 2 is positive, right? And then plugging in the bottom, I'm going to get 1 minus 1/3 the ln of 1. Now we know the ln of 1 is 0, so all of this goes away. So now I have 2 minus 1/3 ln of 2, and then just a minus 1. And then 2 minus 1, that's just 1 minus 1/3 ln of 2. So it's going to be B. Okay, number 29 is absolutely awful. Okay, but let's go ahead and do it anyways. Okay, so for this one, it's another split up question. So this is the integral from 4 to 9. I think I did this with a couple of people today after school. So it's going to be 2 over 2 rad x plus x over 2 rad x. Okay, and let's see if we can make this a little bit nicer with some algebra. So this is going to be the integral from 4 to 9 of the 2's cancel out, but then I'm going to bring this to the top. So square root of x is x to the 1/2. If I bring it to the top, it's going to be x to the -1/2. And then you guys, this little guy right here, I'll do it on the side. This is really x over 2x to the 1/2. But the way to combine these two is just by subtraction, right? So 1 minus 1/2 is 1/2. So this is going to be x to the 1/2 over 2. Okay, so let's go ahead and put that in there. So this is going to be plus x to the 1/2 over 2. Now, I haven't even integrated yet. This is so gross. Okay, so let's do it. If I add 1 to this, I'm going to get x to the 1/2. But if I divide by 1/2, it's the same as multiplying by 2. And if I add 1 to this, I'm going to get x to the 3/2. I still have this over 2 there. But then if I multiply by the reciprocal, that's times 2 over 3. So these guys are actually going to cancel out. So what do I end up getting? Remember, x to the 1/2 is just a square root of x. And then plus x to the 3/2. This means the square root of x cubed. and it's still over 3, and I'm evaluating it from 4 to 9. Lovely. Okay, let's draw our little template. Top minus bottom. Okay, plugging in the 9. The square root of 9 is 3. 3 times 2 is 6. Plus, now you guys, this, okay? How would I do the square root of 9 cubed? I don't know what 9 cubed is. Well, I do, but I don't want to do it, okay? So another way from Algebra 2 trig is you can take the square root of 9 and then cube it and reverse the order. So the square root of 9 is 3. 3 cubed ends up being 27, okay? But then I still have to divide it by 3. 27 divided by 3 is 9. So that was kind of a blast from the past, okay? Now let's plug in the 4. Square root of 4 is 2. 2 times 2 is 4. If I plug the 4 into here, 4 cubed is 64. The square root of 64 is 8. And then it's still being divided by 3. So that's plus 8 over 3. Ew, this thing's getting even worse, okay? 6 plus 9, that's 15. And then minus 4 minus 8 over 3. 15 minus 4 is 11. 11 minus 8 over 3. Make a common denominator. So this is 33 minus 8, which is 25 over 3. Yeah, that was pretty gross. Is that answer even there? Yeah, Dave. All right. Okay, number 30 looks awful, but actually it's not that bad. Okay, so again, it's another split up question. So I'm going to go the integral from 0 to 1 of e to the negative x over e to the negative x plus 1 over e to the negative x. Now, e to the negative x over e to the negative x is just 1. And then if I bring this up, I'm just going to get plus e to the x, not negative x, sorry. And I'm evaluating this from 0 to 1. Okay, so the integral of 1 is x. The integral of e to the x is e to the x. And I'm evaluating from 0 to 1. Again, let's draw our little template. Top minus bottom. If I plug in the 1, I'm going to get 1 plus e to the 1 is just e. And if I plug in the 0, I'm going to get 0 plus e to the 0. Remember, e to the 0, anything to the 0 equals 1. So this is plus 1. So I have 1 plus e minus 0 plus 1 is 1. The 1's cancel, so I just get e. All right. Okay, 31. You have a function that's continuous on the interval from a to b. And it says that this c is in between a and b. And it wants me to find the integral from c to b of f of x. So it wants me to find this. Well, I've got to write myself an equation here, right? You guys remember kind of from, you've probably learned this in geometry, but if you do this plus this, you get all of it, okay? So let's go ahead and do that. So I'm going to have the integral from a to c of f of x. That's this part. Plus the integral from c to b of f of x. That's this part. Equals the integral from a to b of f of x. That's the whole thing. Does that kind of make sense? Now, what am I looking for? Because I forgot. I'm looking for the integral from c to b. So I need this to be all by itself. So how do I move this little dude to the other side? I do it by subtracting. So the integral from c to b of f of x is going to be the integral from a to b of f of x minus the integral from a to c of f of x. And I believe that is D. All right. Since there's only 2 more questions, I'll finish these guys right here. Okay. All right. So I have a continuous function. Which of the following are true? Okay. So let's look at this. Is this true? This kind of looks like net change, but for net change to be true, this has to be a derivative, and it's not. So this is bad. Okay, this is saying if you switch your boundaries, you have to pull out a negative sign. Yeah, that's true. Okay, let's look at this one. It says that the integral from a to b of f of x is always bigger than 0. You guys, this is saying that the area is always above the x-axis. Is that always true? That's not always true. Nope. Okay, and then this right here, d dx, the integral from a to x. You guys, what does this equal? Remember, this is a second fundamental theorem. The x drops in. This should be f of x, not f prime of x. So the answer there should be B. All right, just a little basic integral here. If I add 1, I'm going to get x to the -2 over -2, evaluated from 1 to 2. And you guys, on this one, again, I want to move that x to the -2 to the bottom. So this is going to be 1 over -2x squared, evaluated from 1 to 2. I feel like I've already done this question. Okay, but then we're going to do top minus bottom. If I plug in the 2, that's going to be -1 over 2 squared is 4. 4 times 2 is 8. And if I plug in the 1, I'm going to get -1 over 2. And then 1 squared is 1. 1 times 2 is 2. So this is really -1 over 8 plus 1 over 2. Because haven't we done this question already? I feel like this question was already there. So if I multiply by 4, I'm going to get -1 over 8 plus 4 over 8, which is 3 over 8. Yeah, we've definitely done this question. That's a repeat. All right, number 34. Let k be a constant. What is the value of k? All right, so you guys, if your k is embedded somewhere in your integral, look, you can't be like, I don't know how to do this. You just do the problem, okay? So look. What is the integral of 2x cubed? That's 2x to the 4th over 4. What is the integral of kx squared? That's kx cubed over 3. And what's the integral of 2k? Well, guys, k is just a constant, so it's going to be 2kx. And I'm evaluating this from 0 to 2, and the answer should equal 12. Now, if I plug zeros in, if I take this 0 and plug it in for all the x's, plug it in for here, plug it in for here, and plug it in for here, it's going to zero out, so I can take that away. So let's just replace all the x's with a 2. So this is 2 times 2 to the 4th is 16 all over 4, minus k times, if I plug the 2 into there, I'm going to get 8 over 3. Plus, and if I plug the 2 into there, I'm going to get 2 times 2k, which is 4k, and this should all equal 12. Okay, now let's reduce. This is 4 times 2, which is 8, minus, I'm going to write this in a nicer way, minus 8/3 k plus 4k equals 12. Okay, now let's solve. If I subtract 8 from both sides, I'm going to get -8/3 k plus 4k equals 4. Okay, I can add these guys together. What's -8/3 plus 4? If I do that, 4 over 1, multiply by 3, multiply by 3. So this is really -8/3 plus 12/3, which is 4/3. So this is 4/3 k equals 4. And then if I multiply by the reciprocal, this is 4 times 3/4. They cancel, so k should equal 3. Oh, there it is. All right.